Hello, everyone, and happy Friday. Happy to report that I'm finally starting to feel back to normal. Not quite 100% yet, but definitely a lot better than I was doing last week. Saw many of you in the labs on Wednesday and Thursday. It felt very good to be out of the house and back at work, and to watch all of you learn about loops and if statements this week, a very important couple of concepts for us. And so our task right now is to go through the studio for this week called Gambler's Ruin, and then we also are going to do a pie simulation later on, which will be very fun and interesting for us. So yeah, let's start with the Gambler's Ruin one. We're going to begin our studio by making a class to work with. And I'll go ahead and call it Gambler's Ruin. Here we are. And oops, I forgot to put in the public static little magic words here. That's okay. You can add them yourself if you need to, or copy them from a different file if you need to. Yeah, so once we have that set up, we now need to have our program accept the following inputs. So again, if you need to refer back to code about how to use scanner, that's totally okay. I also do the same thing. I don't have all this stuff memorized myself, even though I've been doing it for years and years. So sometimes I do need to refer back. Well, the scanner stuff I actually do have somewhat memorized, but we're going to make a new scanner here. And once we do that, Eclipse is going to want us to import it, so we'll go ahead and click going to do just that. And now that we have our scanner, we need to accept some inputs. The start amount is the amount of money that we start with. The win chance is a probability, so typically probabilities are represented as a value between 0 and 1 as a percentage. And then the win limit would be our goal for the day. So if I go to the casino with $50, that could be my start amount, and then the win limit might be $100. If I win, if I hit $100 on the day, I'm gonna go home and consider that to be a successful day. So let's go ahead and use our scanner to set this up. I think the types, so for this one, we're probably looking at an integer and a double, and then perhaps another integer here. So let's go ahead and set those up. In.next int. Then we add a double. Win chance is, I believe, what it was called. In.next double. And then finally the win amount, which was another integer. For each of these, we're going to want prompts out in front, so I'm going to go ahead and put in a print statement so that we know what we have to type in. Something like this, and I'll just copy this line a few times for the other values and change the text. Please enter the win chance. And then finally, please enter the win amount. Okay, here's our scanner code that should hopefully accept these values from the user. If we wanted to, we actually could test this code. I think I'm going to go ahead and proceed on to the next step, which is start by simulating a single day. So we want to write code that will repeatedly play until we either hit our win limit or we run out of money. We hit $0. So we're basically, if we want to think about this in the simplest case, we're basically simulating a game where, if the win chance is 50-50, we're flipping a coin. Heads, I win $1. Tails, I lose $1. And we're going to keep flipping that coin over and over and over and over again until we either, win a bunch of money or we lose all of our money. That's our goal right now. So let's go ahead and try to set this up. I think that people can recognize that there's some randomness involved here. So let's start by picking a random value. The way that we do that is by using math.random. Remember, that's going to give us a value between 0 and 1. Our win chance is also a value between 0 and 1, so we should be able to compare the random value that we've selected to our win chance to determine whether we've won or lost. So if our win chance was supposed to be 60, we were going to win 60% of the time, right? then if I choose a random value that is less than that, that would indicate a win, right? 60% of the time that would lead to a win, 40% of the time that would lead to a loss. So I'm looking for cases where the random value that is selected is less than the win chance. That means that I have won. That means that I should receive $1 as my winnings. So I'm going to go ahead and say that in the form of an if statement. I'm comparing two values. I'm asking a question. I have two possible outcomes. I'm either winning or losing $1. That is a great situation to use an if statement. So if the random value selected is less than the win chance, I'll put a little comment here. It says win. Or even more strongly than that, I could put a print statement here. Win. And then to reflect that win, we want to give ourselves $1. So start amount plus would give ourselves $1, right? If the random value that we select is greater than the win chance, that means that we lost. I'm going to use an else statement here. There's only two possible outcomes, so I don't really need an else if. But these are related to each other, so remember that it is important to consider whether the outcomes are related to each other or not when determining whether to use an else statement. So here we'll use an else statement. I'll print out that we lost. And I will lose $1. Minus being the way that we subtract 1 from this value. So I think that we have some code that we can actually start to test here. I may come down here and print out the start amount just to see that the start amount is actually being manipulated properly when we win or lose $1. Let's go ahead and run this code. Please enter the start amount. All right, I'll start with $50. Please enter the win chance. 0.5 is 50%, right? And then please enter the win amount. That's going to be 100. And it told me that I won, and I got 51. So you can see that I did, in fact, win $1, but it only played it once. So we want to play this game repeatedly, and we want to continue playing this game until one of two things happens. Either we run out of money, $0, or we hit our win amount for the day. So in order to perform repetition in code, we need to use a loop. And once we've made that determination, we actually still have another question that we need to ask ourselves, which is what kind of a loop do we want to use? We have two different kinds of loops. There are for loops and there are while loops. And I think in this particular situation, a while loop is going to be the best tool for the job. The reason for that is we do not know how many times this game is going to have to be played before we either lose all of our money or hit our win amount. For loops are great for when we know exactly how many times we need to run through a loop. I need a loop 10 times or X times. Here there's randomness involved. There is a degree of uncertainty. In that situation, while loops are very good tools for us. So I'm going to start constructing a while loop, and notice where I'm putting it. I want to repeat all of this stuff. So I'm going to write a while loop where the brackets surround all of the stuff that I wish to be repeated. I'm also going to take a moment and make sure that I indent this properly so that I can see, even though that doesn't functionally change things, it does help visually represent the fact that this code is the code that is going to be repeated. And so now our task is to figure out what the condition is. There's actually two conditions, right? We want to keep going while, there's a couple of ways we could say this, right? So, we want to keep going while we have money, basically, but we have not yet hit our win amount. So I want to make sure that our value is not 0. So I'll start amount. We could say not equal to 0 here. I think that could potentially work, or maybe greater than 0 while I have money, right? But that's not the only thing. We also need a way to say, start amount is less than the maximum amount that we want. And so some people might try and do something like this. Win amount is greater than. So here we go. This seems like it would be a reasonable statement And in a math class, it probably would be, right? While the start amount is between these two values, we wish to keep going. Unfortunately for the computer, we can only compare two things at a time. So if we wish to have multiple comparisons happening, we need to combine them together. We need to use one of those logical Boolean operators. In this case, I think AND is going to be the proper one. With a little tweak here, while the win amount is greater than the start amount, so I have not yet hit the maximum, and the start amount is greater than 0. So both of these things must be true in order for this code to keep running. Let's give it a try. I'll use the same values as last time. I'm going to use 50. We'll flip a coin, that's 50%, and then the win amount will be 100. Okay. There we go. We see we got a lot more stuff out this time. That's interesting. It says win, 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 win. Oh, we had a very good day at the casino, didn't we? We won every single game that we played. Now, wait a second. What happened there? This is a very, very common thing that I see happen on this studio. Notice that while I did include this loop to repeat a big chunk of code, the random value is not part of that loop. That random value only gets selected once. So I'm choosing one random value and then reusing it. That is not how casino games work, I assure you. I think we actually need to move this code down inside of our loop as well. So let's go ahead and do that, and we'll try our simulation again, see if that affects, well, I believe it almost certainly will. Hopefully we'll see some wins and losses come through this time. There we go. I was about to say we had a very big win streak there at the end, but there are some losses. So it is definitely a mixture, but we did still have a good day, it looks like. It took us a lot longer, you can see, right? It took us a lot longer. We did not just win every single game. It's now a combination of wins and losses. But yes, it's all accounted for. This does appear to be properly simulating, and if you want to tweak it a little bit to see this. Let's the win chance, even if we say like 40%, right? Definitely expect to lose under those under those conditions, right? So it does appear to be working, but we're not done yet. We still have more work to do. So let's take a look at the instructions and see what we have left to do next. So what we want to check is, what we want to do is consider this our job. So what we have effectively simulated here is one day at the casino, one day of work. I am a gambler. I'm going to go to the casino every day. I'm going to wake up, go to the casino every day. That's my job. And I'm going to play games until I hit my win amount or I go broke. We now wish to know if this is a reasonable occupation for us to pursue, if we're going to be able to make money this way. So we need to be able to do this simulation, not just once, but many different times. And so we're going to actually add another variable to this called total simulations. So I'm going to add that to our scanner code up here at the beginning. Simulations is going to be a number of days, so that's probably going to be an integer for us. What did it say? It wanted us to call it total simulations. I'm going to stick with the script. in.nextInt. And so now we want to repeat this simulation this number of times. So we have another case of repetition happening here, right? This time, though, we know exactly how many repetitions we want. There's no ambiguity, there's no uncertainty. I want to make a loop that is going to run this many times. If they type in 10, I want it to run 10 times. If they type in 20, I want it to run 20 times, right? That is a great case for a for loop. You could use a while loop here. That is also an option. But I think a for loop is a better fit. So I'm going to include that for loop here. A for loop has 3 parts. The first part is the variable initialization, the loop variable initialization. I is a traditional loop variable, and we also like to start I at 0. That's a very common starting point for us for reasons that I think will make a little bit more sense next week. We wish to, the second part of the for loop is the condition, similar to the while loop condition, right? It's the same idea. Under what conditions do we want this loop to continue running? So I want this loop to keep going while I is less than total simulations. And then finally, the third part of a for loop is the update statement. So how do we wish the loop variable to change from one iteration to the next? In this case, and as will be the case in many for loops, we just wish for I to increase by 1 each time to represent that we're moving on to the next day. Finally, I will include brackets around the part that I wish to be repeated. So remember, this represents 1 day's worth of work at the casino. I wish to repeat that. So I will include brackets around that entire section. And again, I'm going to make sure that I keep my code nice and clean by indenting this chunk. It makes it very visually easy to see. Notice how the while lines up with the closing bracket and the for lines up with the closing bracket. It's very easy to visually see the structure of this code due to the indentation. Okay, so now I'm expecting this to happen, many times, and I should hopefully get an idea whether this is a viable strategy for us over the long term. If I simulate this, I should be able to, keep track of how many times I win and how many times I lose. So what we want to do is start printing out some information. We want to print out the day number, the number of plays that took place. So I don't think we're currently tracking that. And then whether the day ended in success or in ruin. So let's go ahead and update the code to do this last part. We want to do this for each day. So I think down here, this is the code that actually simulates the gambling. Once the gambling is finished, I will put a print statement. Day. And then now I need to insert a number. So I'm going to use my good friend string concatenation here. And I represents what day we are currently on, right? So we're going to start on day 0, and we're going to keep counting up by 1. So I represents our current day. Now I need to incorporate how many number of plays there are. So I'm not currently keeping track of that. I need a variable to do this, right? So I think maybe I'll come up here and I'll say int plays equals 0. I start with 0 numbers of plays, right? Every time I come in here, this while loop, plays is going to go up by 1. And then by the end of the day, plays should tell me, how many times I actually played the game at the casino. And now I need to indicate whether we have ended in ruin or not. So I'll go ahead and say something like this. I'll say ruin ? And then the way that I can tell whether I've ended in ruin or not is based on the amount of money that I have. So if start amount is equal to 0, let me back up a second here. I'm going to do this slightly differently. I'm going to make a variable. Boolean ruin is equal to whether start amount is equal to 0. If start amount is equal to 0, that means ruin will be true. I went broke that day. If I get down here and start amount is not 0, that means I must have hit my win amount. So I did not go broke that day. All right. So now I can just concatenate that variable on. It'll say either true or false. Let's give this a try. I think I've successfully updated the code to print out the information that's been requested. Let's give it a try. All right, we're going to start with $50. The win chance will be 50%. I think I need to remove some of those other print statements, don't I? We'll do it for 100 days. Oh, well, maybe I don't, because you can see that it did print out what's happened, and it looks a little confusing. On day 0, I played 9,050 times, and I ruined. But then every single day after that, apparently I'm not playing, but still going home broke. So there's a problem that's happening here in the code. This is another very, very, very common problem that students run into on this studio. I'm going to use the debugger to try and help me figure out what's going on here. Some people were able to figure it out without using the debugger, and that's totally fine, but the debugger is a tool that you have at your disposal that you can use to help determine where problems are within your code. So I'm going to show you how you can do that. I set a breakpoint right here on line 24. You know, I don't really care about the scanner stuff up here. That's not the part of the code that I'm worried about. I'm worried about something that's happening down here when I start gambling. So I'm going to go ahead and set the breakpoint on the for loop and then start in debug mode. I am going to have to type in these values, right? So the starting amount of 50, the win chance of 0.5, we'll do 100 for the win amount and 100 days of simulation. And so we aren't going to be able to hit our breakpoint until after we've done that. You can see now it's asking me to switch into debug mode, which is in fact what I would like to do. Over here you can see all of the variables, and they contain the values that I typed in. So the scanner is in fact doing its job, working properly, but that's not really what we're worried about, right? Let's go ahead and see if we can figure out what the problem is in this code. So here we are. I'm going to set plays to 0, and then we're going to start playing the game. We're going to pick random numbers. We're going to win or lose. Now I think the problem is that this is going to take a while, right? For me to simulate. I think the last time we saw that it took over 9,000 plays. That would be a lot of clicking. That would be a lot of clicking for me to go through and simulate 9,000 plays. Could I do it? Yes. I don't really want to. I would like to skip through all of this stuff. I'm actually interested to see what happens on day number 2. So I'm interested in seeing what happens when I goes up a level. We can actually tell the computer to keep going until we hit the breakpoint again. So every time I go through the loop, it will stop at this breakpoint, right? Anytime it hits a breakpoint, it's going to pause, it's going to pause, it's going to pause. So in order to do that, I'm going to click the resume button. What the resume button does for me is that it just tells the computer to keep running until you hit the breakpoint again. And so now here we are. It's finished simulating. It took only 600 plays that time. Okay, so a lot less than 9,000. But we ended in ruin. We lost all of our money. And so now here we are. We can see we're about to start day number 2. And as I start day number 2, you can see I has gone up to 1. That's good. And we're going to keep playing. Plays is 0. Start amount is 100. Win amount is... Oh, we actually won that day. I'm sorry. We did not ruin. We won. Start amount is 100. But wait a second. That's not what start amount is supposed to be. Start amount was supposed to be 50, right? I was supposed to return to the casino with $50. So I think we've already discovered what the problem is. I think that if I click this resume button again, we'll see that after day 1 it says 0 plays, and I won. Ruin is false because it looks like I went to the casino with my win amount. So it just didn't even bother playing the game. It said, you already won. Go home. Well, wait a second. That's a problem, and you know we can see it's going to print that out for every single day. So let's stop this. We need to reset our start amount, or I think in other words, the start amount isn't really a good name, right? Start amount is the amount that we start with every day. What we have is a current amount, and at the beginning of every day, the current amount is equal to the start amount. And then inside of this loop, I really should be using the current amount, not the starting amount, but the current amount. So let's, when I win or lose, I'll update my current amount. And that way the starting amount remains the same. It always is 50. And I will reset my current amount of money every single day as I go to the casino. Very, very common error that we see on this studio. Definitely saw it when I was in the labs, but yeah, just make sure you're updating your variables properly. So now that I've done that, I also removed some of the extra print statements. Let's see if the code simulates a little bit better now. We're going to start with $50, win chance of 50%. $100 over 100 days. Here we go. I definitely start to see that, okay, yes, we are playing different amounts. I am apparently winning every single day. So, oh, and that's because I didn't change this. So let's try that again. I forgot to switch that to be my current amount. Start amount will never be 0. So let's try that again. Oh, I made a mistake. Typed in the wrong number. One more time. 100. There we go. Ah, yes, this looks good. Now I'm seeing a mixture of true and false. So some days I'm winning, some days I'm losing. That's what I would expect for 50% of the time, right? I can see the total number of plays, correct? There we go. Let's make sure we're actually doing everything that we need to do. We need to actually compute an estimate of the ruin rate now. So what is the percentage of times that I'm winning? What is the percentage of the times that I'm coming home with the win amount versus the percentage of times that I'm going home broke? Or I think that's actually what it's asking for. What percentage of the time am I coming home broke? So that's going to require us to, I think, compute another variable. So let's go ahead and keep track of... Notice where I'm creating this variable. I almost created it inside of this for loop, but I think it actually belongs out here. Int number ruin equals 0. So the number of times I've ruined so far is 0. Up here, I need another if statement. If I've ruined, then I'll say number ruin plus plus. Once I'm finished simulating all of the days, all 100 days, I can come down here. Well, it might not be 100, but whatever number it is, I can come down here and do a little bit more math. Double ruin rate is equal to number ruin divided by total simulations, right? The number of times I went broke divided by the total number of simulations will give me the percentage of times that I went broke. It's also saying that we don't actually need to simulate this. We can use a little bit of math to compute this. There's a formula you've been given here. So let's go ahead and do that. We're going to go ahead and compute this formula, and then we can compare the two values side by side and see how accurate our simulation is. So let's go ahead and compute this formula real quick. I'm going to start by computing alpha, actually, since alpha is a term you see up here. So alpha is equal to 1 minus the win chance over the win chance. So I'll say, let me move down here and I'll say expected. Double alpha is equal to 1 minus the win chance over the win chance. Notice how I use parentheses there to enforce order of operations. That is still very important. Now that we have alpha computed, we can look at the first part. So we have two different outcomes depending on what the win chance is. So it looks like we're going to need to use, you see the word if used right there. I mean, I think we're going to need to use that in our code to compute our expected ruin value. One way that we can do this is, say, double... Here, I'll say if the win chance is equal to 0.5, I believe that needs to be a capital C, then we can just say system.out.print the result of this computation, which is 1 minus the start amount over the win limit. Okay? Maybe I'll compute it first. 1 minus the start amount. Wait, that's not right. Parentheses should be around this. Okay, there we go. I called mine win amount, not win limit, so that's more of a naming thing. There we go. That's what the expected ruin will be, and I can just go ahead and print that out. Otherwise, we have a little bit more work to do. In fact, I could probably even move this code down here, since I don't actually need this alpha term computed unless I am doing, this branch. Notice that I am taking alpha to a power, so this is a much more complex thing for us to compute, but we have the ability to do that. You may have had to look up how to do it. That's totally fine. I hope you stumbled across something called math.pow. So we're going to take alpha to the power of start amount, so that will say double expected ruin is equal to math.pow of alpha, and that's going to be to the start amount. The next term is going to be minus alpha to the win limit, math.pow of alpha to the win amount. And then I'm going to put parentheses around that entire thing, since that is the numerator of this expression that we're computing. All of that's going to be over 1 minus alpha to the win limit. So let's go ahead and do a divide. 1 minus math.pow alpha to the win amount. Semicolon. And we'll go ahead and print out that value. Oops. Didn't mean to delete that. There we go. I also need to print out the simulated value. So add a print statement up here. And we have now updated our code to do the arithmetic to tell us this is how many times we actually, went bust, versus this is how often I would expect you to go bust. And we can now really put our code through its paces. We gave you some values here to show, what you can use. We'll do a start amount of 2, win chance of 0.7, win limit of 10 with 500 total simulations, and see how our code handles it. Start amount of 2, win chance of 0.7. The win amount was 10 over 500 simulations, and here we go. The expected ruin rate appears to be 0.18 or 18%. You can see the simulations. We already kind of verified that this is working somewhat appropriately. The ruin rate that's been computed here seems reasonable, considering that we're going to win 70% of the time. That's pretty good. But this doesn't seem good. So our simulated rate is not being computed properly. And let's take a look at that. Consider the type of this is going to be an integer. The type of this is also an integer. In fact, this integer is smaller than this integer. We're doing integer division here. And so that means that we're always going to get 0. This will always end up being 0. We need to include a cast, I believe, in front of one of these in order to make sure that it is a proper data type. There's other ways you can solve this problem, but making sure one of these is a double is one way to do it. So let's go ahead and try again now. Start with 2, 0.7, win amount is 10, and we'll do it for 500 days. There we go. I would say this looks much more reasonable. We got an actual ruin rate of 17.6%. Not too far from our expected ruin rate of 18.3%. I think what's more telling is if you run something that's a little bit more realistic. So if I do an example similar to the one that I had earlier, oops, I messed that up. I typed in the wrong number. So if I do a win chance that is, even slightly less than 50-50, Casino's never going to give you 50-50 on anything, really. I think the best you can get is slightly less than 50-50. And just trying to double my money over 500 days. Let's see. The expected ruin rate is 88%. So we went home broke 88% of the time, even with an almost 50-50% chance of winning. And we actually ruined a slightly worse. So yeah, it's gambling. This simulation is not intended to glorify gambling. In fact, quite the opposite. The deck is literally stacked against you at the casinos. But pay attention to the types of your variables. There's actually another problem with that right here. We didn't run across it because we didn't try a win chance of 0.5 yet since I've written this code. But the same problem exists right here. These are both integers. This is integer division. One of these needs to be converted to a double somehow. So go ahead and include code around that just to make sure it's proper. Okay, I believe that about wraps it up for the first part of the studio. However, there's a second part of the studio, and I realize that many people don't get to this part, and that's okay. Again, you get graded based on your active participation in the studio activity. So if you didn't get to this part, that's totally fine. I do love this problem. It is one of my very favorite computer science problems, so I'm going to go through it real quick. It does not take very long. It's not as long or as involved as the previous example, but it is definitely an interesting one. And before I actually do some code, I'm going to pull up Microsoft Paint here and show you my wonderful paint skills and also kind of illustrate the problem that we're trying to solve. The idea is that we have a dartboard that is square. I'm going to pretend that this is actually, even square, and within that square is where our dartboard is going to lie, right? So we wish to make a simulation of throwing darts, and we're guaranteed to hit somewhere in this square. So we are absolutely guaranteed our darts are going to definitely land somewhere within the square. Let me see if I can make this a little bit bigger so we can see our darts. There we go. Our darts are definitely going to land within the square, but notice that they're not guaranteed to land in the circle. Some of them will land outside of the circle. Some of them will land inside of the circle. And the claim that we're making is that if I throw enough of these darts, I can use this information to help me compute pi. And in order to understand why that is in fact the case, let's do some simple arithmetic. I know I'm going to be a little bit hand-wavy because this is computer science class and not math class, but I do want to at least justify this problem a little bit. If we are assuming a size of 1 here for our square, that means the radius of this is 0.5, right? We know that the area of the circle is going to be based on the radius, pi r squared. Oh, I don't know why I attempted to draw pi like that. That was a risky move in Paint. Pi r squared is the area of the circle, but the radius, so 2 times the radius, that gets me the length of one side, so it's going to be, and then I need to multiply that, so it's going to be 4r squared as the area of the square, 2r on both sides, multiplied together, gets us 4r squared. And as you can see, the ratio of the area to the, we're going to use darts to simulate the areas. So if I throw enough of these darts and I count them, right, and I count the number of darts, I can count whether the dart lands inside of the circle or whether the dart lands outside of the circle. The number of darts that land inside of the circle will give me a rough approximation of the area of the circle. The darts that land inside of the square will give me an approximation of the area of the square. And you can see that the ratio of those two, if I cancel out the r squared, gives me pi over 4. So I should be able to multiply that ratio by 4 to get me the value of pi. I know that was a little hand wavy. I told you it was going to be a little hand wavy. The geometry does check out, right? If you need to derive it a little bit more, you can. But we're going to use the ratio of darts inside of the circle and to the number of darts inside of the square to help us compute pi over 4 and thus pi. So let's go ahead and do that. I'm going to start our simulation. Excuse me. All right. The first thing that we need to do is simulate some dart throws. So in order to simulate where a dart has landed, we're going to treat this as a two-dimensional coordinate system, right? So I need an x coordinate and a y coordinate for my dart. Where has my dart landed? We're going to keep the math simple here. If the length of the square is a size 1, that allows me to very easily use math.random to simulate a dart throw. So something like this, double x is equal to math.random. That'll be a value between 0 and 1. Double y is equal to math.random. That is a value between 0 and 1. So I'm going to pick, a value between 0 and 1 for my x, value between 0 and 1 for my y, and that's where my dart's going to land. My next question is to determine whether it's landed inside of the circle or not. All of the darts land inside of the square. So that makes computing the area of the square somewhat straightforward. That's just the total number of darts thrown. All of them will land in the square. We're that good at throwing darts. So all the darts count towards our square ratio, but only some of them count towards the circle. I need to figure out if the distance where the dart lands is within the radius of the circle, which is going to be our good friend distance formula. So here's our good friend distance formula, x minus x squared plus y minus y squared, where the distance that we're taking is from the center of the circle, right? We're trying to figure out if it's within the radius. So double distance is equal to x minus 0.5, but then we would need to square that. Minus math.pow of y minus 0.5, square that. And then the distance formula says to, that should be an addition. And then it says to take the square root of the entire thing. So flip that sign. And then do a math dot square root around the, whoa, why did it delete that? Okay, math dot square root around the entire expression. Again, I'm just trying to compute the distance. I'm just trying to compute the distance from the dart from the center point of the circle. If the distance is less than the radius, which we know to be 0.5, we know that that dart has landed inside the circle. So we need some way of tracking this or counting it. We also need to recognize the fact that I need to repeat this a whole bunch of times, right? I'm not just going to be throwing one dart. In fact, we want to simulate lots of dart throws. So let's include our friend Scanner here and ask how many dart throws we want. So once I've acquired that information from the user, we can repeat everything. Again, we know how many repetitions we want. I think a for loop is a good tool here. So, whoops, I'll start us out at 0. I is less than the number of darts, so I is going to keep going that many times, right? I want to repeat all of this code, and I'm going to make sure to indent so that I can see that it's now inside of the loop. And we're ready to start actually tracking where these darts land. So I'll make another variable inside circle. Starts at 0, but if I've determined that I land inside the circle, then I'll say inside circle plus plus. And now my argument is that if I come down here, I can compute pi over 4 as the number of darts inside the circle divided by the total number of darts. That's the claim that I'm making, and then I can print out the value of pi as, you know, that number times 4. Be careful, we actually have the same issue here that I just talked about on the last part of this studio, where we're using integers. I need to cast one of these to a double for this to work out. I'm being extra safe in my parentheses here. Let's give it a try. Let's see what we can do. We'll start with a small-ish number of darts. If I say 10 darts, it tells me that pi is 3.6. Well, okay. We're in the right ballpark, but that's clearly not very good. Let's try 100 darts and see. Okay, getting warmer. We're getting warmer. Let's try 1,000. Okay. How many darts do we need to throw before this is gonna do? Oh, that one actually, you can see we got the first digit after the decimal, and that's pretty close. So that's 10,000 darts. All right. 100,000 darts. Let's see, 3.15. Okay. Now we got to do 1,000,000. 1, 2, 3, 4, 5, 6. That's 1,000,000 darts. There's our classic 3.14, but 1, I think, is the next digit. 5. I'm not sure I know. I don't know that many digits of pi, but I know that these aren't right. So let's keep going. We're going to do 10 million. Ooh, all right, 3.1415. I think that's supposed to be a 9. I think that's the last digit of pi that I know. That's supposed to be a 9, so definitely getting more accurate, but still not 100% accurate. It gets more accurate the more darts you throw, but one thing you may have noticed, that last one that I ran with 10 million, it took a second. It didn't take very long, but it took like a second, a noticeable second. Let's try 100 million, see. Noticeable amount of time, right? 3.1417. All right, so, you know, arguably less accurate, but it's random. There is still a degree of randomness involved. Let's see if I can do 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1 billion. It's 1 billion darts. And while this is running, it is going to take a minute. This is a good time for me to talk to you about how computer science actually is a lot more than just getting the code to work properly. As computer scientists, we also care a lot about efficiency. So this is a great example of how even if you have functional code, if it takes too long, it doesn't matter. If it takes the computer, you know, forever to compute whatever it is that you're trying to do, it doesn't matter if your code works or not. We need to be able to get an answer back out in a somewhat reasonable amount of time. This becomes a big deal, and you'll learn a lot more about this should you choose to go on and take more computer science courses. It becomes a pretty big topic within the field. And now I'm just stalling. Oh, there it is. Cool. Yep. 3.1415, and it still didn't get that digit right. Close though. You know, you can see that it is working in the sense that it's getting us closer and closer to pi the more darts that we throw, but this is not a sustainable solution, right? We have other ways of computing pi that are more efficient than this, but it is a fun little simulation that you can perform and play around with, and I'd encourage you to play around with it and see what all you can squeeze out of this fun little simulation. Last thing I wanted to chat about with this video, before I wrap it up, is the homework assignment for this week. So you're going to be tasked with simulating a game this week, a little game called NIM, or you might hear it referred to as pickup sticks. That's kind of how I know the game is called, pickup sticks. But basically, you're going to be playing against the computer. You get to pick up either 1 or 2 sticks per turn. Consider that if I'm playing this game, I don't have to type in 1 or 2. I can type in whatever I want, whatever number I want. But as programmers, we can enforce the rules, and you're going to be asked with enforcing the rules and making sure that if I type in, try to take 7 sticks, that you don't have to let me do that. And also keep in mind that as a person, I can be pretty persistent in those things and type in wrong numbers many times, possibly in a row, and at any point. There is no point in time in which I am forbidden from typing any key on the keyboard. So we need to be prepared to receive strange or unacceptable values from our users at all times. So think about what that might mean for your code. Think about what that might mean for Scanner. If I actually want to verify that what they're typing in is a proper value, what could I put around this code to make sure that I'm going to ask this question however many times it takes until I get a good answer from you, right? Maybe you type in a good answer the first try. Maybe it takes you 100 tries. I want code that'll work in all of those situations. The other thing to keep in mind is that we're going to be asking you to do some more randomness here too for the computer. So you're actually going to be doing some more simulation, making the computer play a game. And you can think a little bit about strategy as well. I would like to also remind you all to please go to Canvas for this and make sure that you check the rubric that is posted. I was in the labs helping demo assignment 1, and there were still people who were surprised that I pulled this up and started asking them questions directly off of the rubric. This is the script that the TAs are following when you turn in your homework assignments. So there should be no surprises. Please take a look at the rubric. Please be prepared for these questions before signing up for the demo. There's no reason that you should be surprised by any of these questions. So take a look at this. Make sure you know exactly what we're asking for on this assignment. And good luck, everybody. That's going to wrap it up for this video. I hope you all have a great weekend. And I am looking very much forward to seeing you all in class, in person, and healthy on Monday.